Hey there, this is Dr. Rishi from the Learners Academy, and today we are going to talk about one of the most important topics that we teach in standard 9th and standard 10th. Yes, you guessed it correctly. We are going to talk about trigonometry. Trigono, the name itself indicates that we are going to talk about something that is involving 3. In this case, we are going to talk about triangles. Not only triangles in general, but we are going to talk about a very special kind of triangle called the right angle triangle. So let us first understand where we use trigonometry in our real life. When we were young, in our early growing ages, the science teacher came up and they would teach us, or they would tell us, the diameter of the sun, the distance of Earth from the sun. Have you ever wondered how someone actually was able to calculate this distance, or someone was actually able to count the diameter of say sun, moon, or various planets that are there? The answer lies in trigonometry. So without any delay, let us dive into the basics of trigonometry. Today we are going to talk about the basic ratios that are involved in trigonometry and how we derive these ratios. Before we dive into the topic of trigonometry, we need to understand the concept of similarity. तो भैया similarity क्या है? Similarity मतलब दो figures, two geometric figures, they are equal in shape. दोनों का shape same है, sizes अलग हो सकते हैं. So the shapes are same, the sizes are different, or the sizes may be different, and it can be about anything in the world. The easiest example of similarity is, say suppose we go to Agra and we see Taj Mahal there, and when we are returning back, we buy a small memento from Agra, which makes us remember our trip to Agra. So we will be buying, many people buy a small showpiece of Taj Mahal. Now this small showpiece is somewhat similar to the real Taj Mahal. This can be considered as an example of similarity of two figures, or this is how we can say that two figures are similar. Other example of similarity would be, currently we have 3D printers and we can print our own figurines using a 3D printer. So if I have to print my own figurine of a very small size, it would be exactly similar to me, however, the size would be different. It may be smaller than my actual size. So let us consider similarity of triangles first. So we were talking about trigonometry. When we talk about trigonometry, we have a special kind of triangle, that is a right angle triangle. And before we go ahead and understand trigonometry, we need to understand similarity of triangles. In our case, it would be similarity of right angled triangles. So let us consider a triangle ABC right angled at B, and let us have another triangle AB dash C dash, and one more AB double dash C double dash. What can we see from the figure? There are three triangles that we have. One of their angle is right angled and one angle is common. So these three triangles would be similar by AA test of similarity. So I can say that triangle ABC is similar to triangle AB dash C dash is similar to triangle AB double dash C double dash. Now what does this imply? If two triangles are similar, then the ratios of their sides are going to be equal. So what would this mean is, first BC upon AB, BC upon AC will be equal to B dash C dash upon AC dash will be equal to B double dash C double dash upon AC double dash. Similarly, AB upon AC will be equal to AB dash upon AC dash will be equal to AB double dash upon AC double dash. Also, the third side, BC upon AB will be equal to B dash C dash upon AB dash will be equal to B double dash C double dash upon AB double dash. Since these three sides are having equal ratios, the reciprocal ratios should also be equal. So I can also write AB upon BC is equal to AB dash upon B dash C dash is equal to AB double dash upon B double dash C double dash. Also, the reciprocal of this ratio would be equal and the reciprocal of this ratio would also be equal. Now, what we have done in trigonometry is we have named all these 6 ratios. If you can see, if I extend this line AB to no matter how long and this line AC to no matter whatever value I want, as long as this is BC is perpendicular to AB, the ratios are still going to be same. That means these ratios for this particular angle are going to be same always. This is the origin for the 6 ratios that we study in trigonometry. So the trigonometric ratios are basically these 6 ratios with a specific name. Let us go ahead and see what these trigonometric ratios are. So let us consider a right angled triangle ABC, right angled at B, and let us define angle A as theta. Theta is a Greek letter. We would be using it quite often when we are dealing with trigonometry. Now, let us define these 2 sides. So, as we know in a in a right angle triangle, the side opposite to the right angle is called the hypotenuse. The line neighboring our angle theta, we will call it as the adjacent side, and the side opposite to the theta would be called as the opposite side. So side BC will be called as the opposite side. Now, let us define all the 6 ratios that we had seen in the previous part. So the first trigonometric ratio that we study is sine theta. This is the full form of the ratio sine theta. We generally use the short form, that is sine theta, and it is defined as opposite side upon hypotenuse. The second theta, the second trigonometric ratio that we have is cosine theta. It is defined as, it is also known as cos theta, and it is defined as adjacent side upon hypotenuse. The third one we have is tangent theta, which is also known as tan theta, and is defined as opposite side upon adjacent side. The fourth one is cotangent theta, also known as cot theta. The short form is defined as adjacent side upon opposite side. The fifth one is secant theta, short form is sec theta, and it is defined as hypotenuse upon adjacent side. The last one is cosecant theta. The short form is cosec theta, and it is defined as hypotenuse upon opposite side. So these are the 6 ratios that we can have in trigonometry. Obviously, they are defined in a very specific manner, and I have listed them in a very specific manner as well. This is because I'm also going to teach you a trick to remember these ratios in case needed under stressful conditions. Before we go ahead, let us write down which sides would be there with reference to this triangle. So here it would be BC upon AC, AB upon BC upon AB, AB upon BC, AC upon AB, and AC upon BC. Now, the trick to remember the ratios is very simple. We have to write them in this particular form or this particular sequence. We have to write the ratios in this particular sequence: sine, cos, tan, cot, sec, and cosec. And if you see the numerators, we can write the acronym OA, OA, HyHy. So if you look at the numerator, it would be OA, OA-HyHy when we go from numerator to denominator, and it would be OA, OA-HyHy if we go from bottom to top. Today, in this video, we defined the 6 trigonometric ratios and how we can remember them along with the basics of trigonometry. In the next session, we would be talking more about trigonometry. Till then, have a great day. This was Dr. Rishi from the Learners Academy. Thank you.